Welcome everyone. My name is Fred Sauer. I'm a developer advocate for Google Web Toolkit and Google App Engine. Today I want to talk to you about Google Web Toolkit and give you mostly an introductory overview of the features, capabilities, give you a good sense of what's there, what do you get when you open the box or open the zip archive, and what you can do with it. And then for those of you that have already written Gwt applications, we'll go into some of the details that are useful for larger projects, more complex projects. So these are some of the lesser known features inside of GWT that can make you more productive or just give you more power as a developer. So our agenda for today looks something like this. We have a little bit of introduction on GWT. We talk about selecting the language. Why is it that we chose Java as a language for you to write your source code in? There's actually some very important reasons why we do that. We'll go through a tour of features, and then we talk about developer productivity, which is one of the key benefits of GWT, and then talk about compiler magic and some of those in-depth features. So first we should kind of start with the GWT story. What are the different components and how do they play in? And I've broken it down roughly like this, which is any software development cycle. You write your code, you debug it, you optimize it, and then you run it. And you loop back and forth through some of these things. But GWT has a very specific role to play in different parts of this story. Specifically, when you write your code, you want to be very productive as a developer. You want to use powerful abstractions. You want to use tools that are state-of-the-art. You want to use very powerful IDEs that let you refactor code very quickly so you can focus on your application. And this is one of the reasons that we chose Java as a language for you to write your Ajax applications in. Now on the debugging side, you kind of want the same thing. You want to be productive. You want to be able to do all the things that Java developers are used to doing, which is stepping through your code, debugging variables on the fly, setting breakpoints. These are all normal things for a Java developer. In the optimization phase, you want the computer or the compiler to do all the magic for you. You don't want to hand optimize methods if the computer can do it for you automatically. At the same time, anything that a compiler can do to optimize your code is something that you don't have to worry about and allows you to maybe use a higher level abstraction, something that makes you more productive. So these cycles kind of feed back into each other. And then the final step in running and deploying the code, what you don't want is users to have to install plugins, have to do difficult things. Really, as a premise, we started with building Ajax applications, powerful web applications. And the best way to deploy those applications is using JavaScript, HTML, and CSS, no plugins. And we'll get back to that in a little bit. GWT has been around for quite some time. It was launched in May of 2006 at Java 1. This surprises many people. They think it's something new that they've just recently heard about. In fact, they've been through quite a number of important releases. And we have a big one coming up in the fall, towards the end of this year, with GWT 2.0. There's really just a behemoth of a release with lots of features. We thought the Gwt 1.5 release was big, which it was at the time, but this is going to kind of dwarf that release. Lots of interesting stuff. If you're interested and a little bit adventurous, you can actually play with most of those features today using SVN trunk, so just building the source code directly. But if you're one of those companies that likes to hold off a little bit longer until it's actually been stamped with a release approval, then have to wait probably to the end of the year. Any talk on GWT should really have a slide about the mission statement, because it drives a lot of the decisions that we make when we develop the product. I've highlighted a few things, but the key thing that you should grab from here is that we focus specifically on the user. And we want to build no-compromise Ajax applications that are very powerful. And a way to doing that is making you very productive as a developer. But you're always second to that user. Any decision that we make, a design decision where we have to make a trade-off between your productivity and an end user experience, we're always going to choose the end user. Having said that, a lot of my talk is about your productivity, because that's one of the ways in which you can deliver powerful apps for your users. But at the end of the day, you'll see some of the decisions that we've made, some of the hoops that you maybe have to jump through in Ajax applications. We've made it easier, but some of that is still there, just because we have to deliver a powerful user interface. So I talked about these two key components: productivity for developers and performance for end users. And the same themes keep coming back here, but productivity comes from the Java language that we selected, from all the tools, the libraries, just the know-how, all the knowledge that you have about Java. All of that makes you more productive. And then performance, we have a whole bag of tricks. It's literally an endless list of tricks that we do to make every download just slightly smaller than the last time we compiled the application, to make your program slightly faster in one browser if we can make a tweak that's specific to that browser. Obviously, we don't want plugins, because that gives a really bad user experience. And this is one of those user experiences. This is me on my iPhone trying to browse to a website. I'm being prompted to install a Flash plugin. Of course, Flash is not available for my platform. So this is a very poor user experience, not what we want. Gwt, I've kind of thrown some of these things around. A compiler, we're using Java to compile the JavaScript. And if you haven't really looked at Gwt before, you're probably wondering where all this is coming from. What's kind of the big picture? Well, the big picture is we want to build applications for users. And at Google, we believe that the web as a platform has won. I don't know about all of you, but I spend much of my day in a web browser. I have multiple tabs open. These are my applications. This is where my documentation lives. This is where my email lives, my online banking. Most of my life lives here. It moves from device to device. And very little do I find myself in actually a binary application on my desktop. The Eclipse IDE might be a good exception to that. So what we want to do is build powerful applications for users, and we believe the web is the platform. We don't want plugins. We want a good user experience. We want it to run everywhere. That was kind of the promise of Java applets, but for various historical reasons that didn't quite work out the way some of us had hoped. And so what we have is HTML, CSS, and JavaScript. Those are the things that run on any browser, or any modern browser at least, and on many modern devices today. So that's our target. I've talked a little bit about productivity, where Java, in our opinion, gives us the best productivity experience when building web applications. Java is a language that's really well known. Libraries, IDEs, just this whole ecosystem that revolves around Java. Java has some other unique attributes in that it's a statically typed language, and I'll get into that in a little bit. That provides us even extra benefits or a bonus, as it were. So we have these two ends of the spectrum. We have the web platform that we want to deploy to, that's ever evolving, and with new browsers, new features, new capabilities. And then we have the Java programming model that we want to stick with. So we need to bridge the two together, and that's where Gwt comes in. At the core of it is a compiler. It's a multiple browser or cross-browser compiler that takes the Java code that you write and converts it into JavaScript, CSS, and HTML that will execute anywhere. Once we've started with that premise, we do a lot of things on top of that to give the user the best possible experience, to make you the most productive developer. And that's really what this talk is about. So let's make it a little bit more specific. Let's say we're building a web application, and as we manipulate the DOM, the document object model, we want to update dynamically on the page a portion of text. And within the element on a page, for example, we might want to change the text description. So there's a way of doing that. It's setting the inner text is really what we want. And across different browsers, you can kind of write down a matrix of features and capabilities and test performance. And what you see is that across the top, the yellow bar represents the cross-platform way, the single method that works in every single browser. if you use this code snippet, then in every single browser you can change the text. It turns out this is not the fastest way of doing it in any browser. So if you have a demanding application that does a lot of things, making this choice here is a poor choice from a user perspective. For a developer, it's easy because you're picking the lowest common denominator. If we try to pick one of the other methods for setting the inner text, we find that it's only available on one browser or two browsers, or is still not the fastest choice across all of them. Now, what we want in an ideal world is that we pick the fastest choice in each case, that we pick the green choice. And that gives us, for each and every single browser, increased performance. So in a perfect world, we'd have one version of our code for IE, another version for Firefox, another version for Safari, another version for Opera. Well, that's a maintenance nightmare. And in JavaScript land, what some have tried to do is they'll set up kind of if-then-else statements. And you can try to bind them to variables. You can do all sorts of tricks to improve the performance. But at the end of the day, what you're buying is a single package that contains 4 different versions of certain DOM-specific code that the user has to download. And then at runtime, you figure out which version you're going to call. Is the current browser IE, then I use this method. If it's Firefox, I use this method. The problem with that is you still have this overhead of checking which browser you're in. And even if you can kind of push that under the rug, you still have the overhead of the extra code that you need to download. And Gwt comes to the rescue and makes all of this go away. What we do is we take your source code and we take all the libraries that Gwt comes with. These are the DOM manipulation APIs. And we have, across those APIs, we have implementations for every single browser. We have picked the optimal implementation for each browser. We've baked them all in together. And we've also baked in that if-then-else statement that I just talked about in the JavaScript world. So if IE, then do this. If Firefox, do that. But then the compiler does its magic, and it says, OK, I'm going to start compiling your code. I have this monolithic version, and I'm going to split it into 4 different versions. And I'm going to compile each one separately. In the first version, I'm going to hard code the value of the current user agent, the current browser, to IE. In the second version, I'm going to hard code Firefox, and so on. And then those 4 versions get independently compiled. And I end up with 4 different versions of my application, one that is completely optimized for Internet Explorer, another one for Firefox, another one for Chrome. And then we bake in a little selection script at the front that the user downloads and tells them which version of your app to grab. And now we get the best of both worlds. You get to write in your Java abstractions. You get to use a very simple API to access the DOM to set the inner text. And the compiler does the hard work of converting that into 4 different versions. And your users get the best because they only download the code that's applicable to them. So IE users only download the IE version of your source code, of your compiled application. So really, it's a win-win-win situation, as this guy likes to represent. A more powerful web made easier. At Google, we like to eat our own dog food. And what that means is we use our own products. So when we build Gmail and we make changes to it, we use it ourselves first. And if we can't stand it, we're certainly not going to ship it out. We have to like it and love it first, and then we ship it out to you. One of the products that we recently launched was Google Wave. And this is an amazing product from a communication, collaboration experience. It's really hard to describe if you haven't seen it. There's some good videos online. But imagine that you take email and instant messaging and online documentation and collaboration, and you throw it all in a blender and you mix it up, and you create this new form of communication that's real time and that blurs the boundaries between documentation and communication and email. And what you have is Google Wave. Now, Google Wave was built with Gwt, and when the team in Sydney started to work on Google Wave, they were a little bit uncertain about Gwt. It's not something they had tried before. They were a little bit hesitant. They had some other ideas. But quickly after they started using it, They simply fell in love with it, and they've since then made the claim that they would have never really been able to produce this product without GWT. It was such a significant impact to their development that literally this product would not have occurred had it not been for GWT solving their problems along the way and allowing them to focus on the application. Now this is a very rich and dynamic application, fairly complex, but you can build simple applications with GWT as well. You can build a date picker. In fact, we have date pickers, and you can slap them on an existing HTML page. So GWT is very granular. You can go anything from just incremental functionality on a website to building full-fledged applications. I almost want to say desktop applications, but this is, of course, actually in a browser. There's many, many sites. We have a little gallery where you can see different things that people have built, screenshots, lots of little fun projects. So I said I would talk about the Java language, and I have a little bit already. But where we start off with is the Java language runtime and tools. And I won't step through this whole diagram, but the key points to take away are that with the Java language and its tools, you're able, as a developer, to deliver applications more quickly than you can in many other languages. With the great IDEs and the refactoring and all those capabilities, you're able to iterate faster. So you can change your mind, you can deliver a new release much quicker. And then a very important feature, the static analysis, that Java is a static language, which means that it means several things, but one of them is that when you declare a variable and you declare that, say, this is an integer, it is forever an integer. You can never come back and change it and let it be a string. It's also true if you had, like, say, a shape object and you have subclasses like triangle and square. Let's say you declare a variable a triangle. It is forever and ever a triangle in your source code. And that's important because the compiler can then reason about your program, and it can see that if you only ever return a triangle from a certain method, that even though the return type is shape, it now knows that it only needs the triangle source code, and it can actually throw the square away. And it can throw away some of the shape methods as well that you've overwritten. The fact that something is an integer will limit the number of methods that you can call on it. So you can never call string methods on an integer object. And with these restrictions, you can further reason about the program and understand that certain methods are never overridden. So I can safely inline those contexts. And there's many of these things that a static language provides that allows the GWT compiler to optimize your code and make it smaller and smaller before it's delivered to the end user. And Java does other things like give you good code completion. This is, again, because it's a static language. You might be wondering why there's not an IDE as good as or capabilities as good as Java's for, say, JavaScript or other dynamic languages. And one of the key reasons is that you can't do some of this for a dynamic language. You see here that there's a button object that has been declared as a type button. It's forever and ever a button. And so my IDE can give me code completion and tell me what the possible methods are that I can call in this object. Now, if this were, say, JavaScript, then button could be assigned at runtime to something else. I could do an eval. I could just actually take a string and assign it an integer, and now it's an integer magically. The next moment it's undefined or it's null. Then I can reassign it to a function. So because of that, the tools can do powerful things. Compilers can help as well. Here's a little code snippet, nice little exercise that contains one bug, at least one that I found. And it's pretty hard to find. You can stare at this for a while. And so this is a little function that you pass in an array of integer values. And the job of this function is to return the maximum value. So we pick the first value, value's 0, and we put that in the maximum. And then we loop through the remaining results. And if we find one that's even higher, then we set it. And for some reason, this code only sometimes works. Now, that's kind of frustrating, because the first time we tested it, it actually just worked. And so we went on about our way, and then later we had to discover this. Why can't our compiler tell us that this code is wrong? Well, in JavaScript, this is completely valid code. But a human who's understood this will say, well, this is stupid code. So now I'll do the same fragment in Java, and our IDE won't even let us compile it. And as we're typing, it already tells us what the error is. The word maximum has been misspelled. So we'll go back and show that. Yep, it was misspelled. These types of errors are actually pretty common in JavaScript. There are things called Expando Properties, where you can, on any object, you can just set a property. So if you have a variable or an object foo, you can say foo.a is something, foo.b is something. Well, when you start becoming descriptive with those variable names, you get these longer ones. And you access them, and you expect foo.maximum left value. And you do a typo somewhere in there, you'll get a bug just like this. So we should start talking a little bit about what are some of the other features in GWT. Do a feature tour. I mentioned at the heart of GWT is this compiler that takes your Java and compiles it to JavaScript. It does a lot of other things as well. In fact, it can take your images and compile them into a single image. It can take your CSS and your Java source code and validate them against each other and tell you that you have CSS rules that aren't used, that you've specified CSS in your code that actually doesn't even exist. We can optimize the CSS and compile different versions of the CSS for IE, for Firefox, etc. We can also inline a lot of resources. You know, many applications have little bitty images, those the little plus sign in front of a tree to expand. You know, it's a 7 by 7 pixel image. When you fetch that from the server, that's one HTTP round trip. And you start adding up all these images that need to be fetched. That starts to get expensive pretty quickly. What GWT can do is take those little images and actually inline them into the JavaScript. And we'll talk about that a little bit. Oh, I should mention generators here. Generators are kind of a key part of GWT, and this is part of the learning process. When you get to learn GWT, there's some, call them GWT-isms, where we have this method called gwt.create. And you pass in a Java interface, and then the generator at compile time will magically compile this Java class, which will be an instance of that interface and will provide this functionality. And this is a trick that we use to provide the different implementations for the different browsers. It's also what we use to provide the spriting of images, the bundling of multiple images together. GWT is a lot more than a compiler, though. There's many different components to it. It's set up to be broken up into pieces that are independently usable and useful. So you can just stick with the compiler and use just that. The widget libraries are there for you to use, or they're optionally, you can put them away. Many different things. So let's look at the example of grouping images together and how that works and where the benefits actually come from. Now we all think about, when we're optimizing our application, about bandwidth. We think that, you know, because of a limited bandwidth between the server and the client, that's the reason our application startup time is slow. So if I go to, let's say I go to the google.com homepage, there's not a lot on there. There's just a logo and a box. But there's still some resources that need to be fetched, like the image. What the web server does, or the browser does, is it first does a DNS lookup. When you type in google.com, your browser does a DNS lookup, which is a round trip to a DNS server and says, what's the IP address for google.com? That server responds back. Then the web browser makes a connection to that IP address to port 80. That is one round trip, and it's a TCP/IP round trip. This is setting up the physical connection or the logical connection from your client, from your browser, to the web server. And the web server responds and says, yes, I accept this connection to port 80. The client then, as a third step, makes an HTTP connection to the server and requests the page / index.html. The web server replies with the HTML. That streams down to the client. And then the web browser inspects the HTML, begins to parse it and render it on the page. And along the way, it finds an image tag. And it says, oh, image tag, I need another resource. Looks at the source attribute. It says, oh, I need google.png. And it then goes to the same web server on the existing TCP/IP connection and does an HTTP request for the image. Once the server receives that, it sends that downstream. Now, if I have CSS links in my document, if I have multiple images, each one of these is an HTTP round trip. So my packet from my client over the network travels to the web server receives it and sends it back. And I'm talking about this in great detail because it's often misunderstood where the performance delay comes from. I said many of us think about bandwidth. That is, there's a limited bandwidth between me and the server, and that's why it takes a while for that page to load. So if I have a page with lots of images, maybe it takes 2, 3, 4 seconds before that page loads. It turns out that even if you have infinite bandwidth, that page will not load instantly. And the reason is that latency plays a really important role. I was talking about the DNS lookup, where you go to the server. Then you set up a TCP connection, round trip to the server. Then you make an HTTP request. It's a round trip to the server. Round trip is, the best case is speed of light. I send a packet here and it gets received there some moments of time later. And even with infinite bandwidth, if you send a packet from here to Chicago, it's about 20 milliseconds. Before it gets back, it's about 40 milliseconds. So every time you make an HTTP request, even going straight, speed of light, infinite bandwidth, that's 40 milliseconds that you've just lost. Now, if you have 10 images on your page and you're making 10 requests, you multiply that by 10 and you have 400 milliseconds. That's almost half a second, and you're going at infinite bandwidth. So you can see how a lot of resources quickly adds up. So one of the key things that we can do to improve the user experience is reduce the number of HTTP round trips. If we can take 2 things and combine them into one, or take 5 things and combine them into one, we can make a huge improvement even if we don't have a lot of bandwidth. So this is what the image bundle, or now client bundle, is all about. We have this application, we have 11 images in it. What if we could combine them together into a single image? So we could fetch it with a single HTTP request. We'd go from 11 to 1. We would save 10 round trips. If the server is in Chicago, we save 400 milliseconds. We probably save more because the actual ping time is probably like 50, maybe 60 milliseconds. Because the fiber, they don't lay it in a straight line, and there's repeaters, and there's other things that happen. If you just look at pure bytes, each image has some overhead. There's headers, there's palette information, the image may not be fully compressed, and if you add this all up, it turns out that just bundling the image together gets you a savings. In this case, we went from 20K to about 7K. So we just got a straight improvement by number of bytes. We also saved 10 HTTP round trips. So this is a tremendous impact. Now GWT takes it a step further and says, why would I, every time my user visits the website, why would I go to the web server and ask the web server if this image has changed? Because that's what a browser does. When you visit a web page, it checks the resources and says, oh, I need this image, but I already have one, but I don't know if it's good enough. It's been a while since I checked. So it talks to the server and says, has this image changed? Has this resource changed? And the web server often replies back, I think it's HTTP 304, not modified. That's great, but that's 40 milliseconds that just went out the window. If I somehow knew that the resource hadn't changed, I could save myself the time. And so what GWT does is it calculates the checksum of all the images, and it changes this. It produces a file name for those combined images that is the MD5 checksum plus an extension .cache.png. And this hard-coded file name is baked into your application. We do the same thing with other resources. So CSS files that are compiled, we bake in this hard-coded file name. And in addition to that, you can then configure your web server to indicate that these resources are permanently cacheable. They never ever have to be checked for freshness. When any of those images changes, the checksum changes, and so you get a new file name. And we do this globally, actually, for your applications. We take all your source code, all your images, everything that you input into the compiler, everything that you throw into the funnel. We calculate one big checksum, and that produces the file name that comes out. So your compiled application is actually some long file name .cache.js for JavaScript. And as soon as you change one byte of code anywhere in your application, we generate a new file name. So the old version of your application can still be cached forever. It doesn't hurt. But as soon as you change your application, there's a new version, a new file to be fetched. And by doing this, we greatly improve the user experience on subsequent visits to the website. So the first time, yes, we have to fetch the image bundle. There's no way around that. But once we've fetched it, and the browser knows it can be cached forever, the next time I visit the website, the application's already cached, the sprite is already cached, the CSS file is already cached. The application can come up instantly and almost be served off of disk. So that's a lot. Let's look at some lightweight features. So in the good Web 1.0 days, when the internet was really taking off, we had this thing called a back button. And the back button, it was great, right? You could go to the last thing you were doing, and it always just worked. The forward button was a little trickier. Sometimes if you went past a post form, it would ask you if you wanted to resubmit your credit card and get charged again. But it sort of worked. Regular web page browsing, you could go back, you could go forward. When Web 2.0 first took off, we lost that functionality. People built these Ajax applications, but as soon as you hit back, you'd go to the previous website. You could spend half an hour on a site, and the screen would change, and everything would happen. You hit back, boom, I'm gone. And that is something that it was a little bit unfortunate. It turns out there were enough features in the browser that we could actually make this work. And the hack that the Ajax world discovered was the hash fragment, this little bookmark where you put a pound sign at the end of the URL, and you put a name. This turns out to be a perfect way to store Ajax state. And so GWT has a number of abstractions to take care of this. So here at the top, you see that little hash fragment. And we enable you to write your application in such a way that you can use the back button, the forward button, and you as a developer get to decide what happens when you hit the back button. If you're in a step 3 of a 5-step wizard, you go back to the step 2, if that's what you want. If you want to actually go back to the previous website the user is on, you can do that too. It's completely up to you. But we make it easy. You want things like rich text editing inside the browser. Those are things that are really hard to do across multiple browsers, so we just provide you the widgets. If you're building applications, you probably quickly realize that not all users speak the same language as you do. Hopefully your application is becoming very popular. It's spreading globally, and so you want internationalization to work. You need UTF-8 to work, right-to-left scripts. Also, you may be concerned about accessibility, or hopefully you are, that users that maybe need screen readers or use the keyboard solely for navigation are able to use your website as well. So these are all things that are baked into GWT. We have a large number of widget libraries that the community has created that you can select from. I'm going to shamelessly plug some of my own projects. This is actually how I got into GWT. I started my own little project, and I needed to move something from one side of the page to the other. I wanted to drag and drop in the browser. And I liked GWT. It was doing everything for me except for drag and drop. And I started to code it up. The basics of drag and drop are pretty easy. You handle mouse events. When the user clicks down, you record where they are. When they move, you make some thing on the page kind of move with them, and then when they let go of the mouse, your object has moved. It turns out in the web browser it's a little more tricky than that to get it right in all cases. So very quickly I got distracted from my actual goal and started building this side project called GWT-D&D for drag and drop. And that project started living a life of its own. As soon as I open sourced it, Other people would send me comments about it. They liked it, but it didn't do this thing or that thing. Then they had weird cases where they were able to break it. They had interesting cases I'd never thought of doing where they wanted it to work. They had more use cases. They wanted to be able to select multiple objects. And before I knew it, I'd forgotten what my original project was, and I was now the maintainer of Gwt D&D. That has continued ever since. I still maintain that project. I've started a couple others since then. But ultimately, through my familiarity with GWT and getting to know the engineering team and working out in the open source, it's how I came to be at Google and be a developer advocate for GWT. One of the screenshots you see in here is a little game. I can hopefully bring that up a little bit later. My son did the artwork for that, and that was a little weekend project to do graphics inside the web browser, move things around. It's kind of fun. So developer productivity, because I think most of us are probably developers or work daily with developers and really care about our productivity. So if you're familiar with GWT, we had something called hosted mode. That is now been renamed development mode, or will be for Gwt 2.0. So start looking out for that terminology. What was web mode is now production mode. We've kind of cleared up the terminology a little bit. The point is that there's two different ways in which you work with GWT. The second one, the production mode, is how your users interact with your application. You take your source code, you run it through the compiler. Out on the other side comes JavaScript, HTML, and CSS. You deploy this on the web server, and that's it. You as a developer, though, want some more tricks in your bag. You want to be able to step through your code, use a Java debugger, inspect variables, hot swap code out while you're debugging. So as your program is paused, you want to be able to change a line of code and actually have that take effect immediately. The compiler option doesn't really work for that. So we have this thing called development mode. This is where we execute your source code, but we don't do the compiled version of it, the JavaScript version. We actually run the original Java version on top of a regular JVM. So you're inside Eclipse, and you're debugging Java code. But at the same time, you're looking at a web browser. And that web browser has your application. And as you step through a line of code, the JVM is executing the Java code, but this little plugin is doing the same thing in the browser and kind of taking the net results of what you just did, any DOM manipulations, any event handling in the browser, and executing it there. So you can debug and write a real application in a web browser, even though you get to live in Java land. This is really cool the first time you do this. So what does it look like? This is a little diagram of what GWT 2.0 does. This was known as OOPHM, if you've seen it, UFM, out of process hosted mode. That name was much too long. That's why we called it development mode. So you start with a regular browser that you've installed this developer plugin. I said before there's no plugins. That's true for your users. But if you want to be really productive, this plugin will help you iterate faster and debug faster. So you have a regular web browser and a plugin installed. And Eclipse is running this JVM. So you run your program just like you would a Java program. And we start up inside that JVM, we start up two servers. We start up a web server that's going to serve your HTML files, your static resources. This is a regular Jetty web server. Then we have a code server. This is the special thing that serves up statements of Java that get shipped to the browser. You type in a URL, you paste in a URL for your application. It fetches from localhost 8080 from this web server, this HTML page, which appears. The HTML page contains an activation for the plugin. The plugin then looks at the URL, and at the end of the URL, there's a reference to where the code server actually lives. And so it connects to the code server and gets its first fragment of code and starts executing your Ajax application. All of this gives you kind of this magic experience where you develop in Eclipse, and you can use any IDE. I keep saying Eclipse because that's my favorite, and that's where we've built the plugin. But you can do it really in any IDE. You drive the process, you change code, you do all those great things, and you debug your application JavaScript. So let's see. The plugin provides quite a few capabilities. I won't go over them in detail. I'll just share this screenshot with you. So here is probably the familiar Eclipse background. I've set a breakpoint on this method, and let's see, the method is dialogbox.hide, and it's inside a click handler. And so this is Java code. This is regular IDE, and you see the web browser there in the top left corner, and I click on the send button. So this is an Ajax application. I click send, and my IDE suddenly starts flashing or pops to the front, and it's paused on this breakpoint. And the browser locks up because I've hit send, but the code can't execute beyond this. And I can look up here on the right. That's where the variables are, the usual place. I can see a stack trace. I can do everything that I expect. And then when I hit F8 to resume my program, the browser continues, and I can keep going. So this is really where Gwt is magic. Now, go ahead. The question is, if you were to open Firebug here, would you see JavaScript executing? And the answer is really no. So what you would see in Firebug is the DOM. You would see all your objects. You would see your CSS. You could modify the CSS. You would see the network traffic. You could see all the usual things. But what you would not do is see a big block of JavaScript where you would set breakpoints there. Instead, this plugin is feeding the browser a line of code at a time, as it were. Now, if you do want to debug JavaScript, you can use production mode. You can compile your application to JavaScript, the same thing that ships to your users, and then you have a regular Ajax source file that you can step through, and the JVM is not involved, the plugin is not involved. So you can kind of pick and choose how you do that. So this is the section where I want to dive into some of the issues that people have on larger projects, or to make them a little bit more productive. Kind of some tips, guidelines, list of features to look at. One of the big ones that are just, a lot of these are just good engineering best practices. So you test your code, you test your code, and you test your code. And of course you've written automated tests for your code. Because how else do you know that when you commit a change that it didn't break something else somewhere else? How else do you prevent yourself from a week later having to track down what is the thing that actually broke that code? You want to know immediately. So kind of a test-driven development, or at least having some sort of continuous integration or some test suite where after you make a change you can run a suite of tests, and it will tell you, it will confirm either that everything works or will tell you where the breakage is, so you can quickly find it. We provide extra functionality for JUnit unit tests. You can use Selenium or WebDriver if you want to actually run a browser and drive it remotely. There's a cool feature in Gwt called Debug Ids, where you can optionally compile a version of your application that has IDs on certain elements. This allows you to use automated testing tools to find those elements at runtime. For example, if you were writing the Google homepage, you could assign a special ID to the search box and the search button, and then your Selenium or WebDriver can grab that element kind of by its handle, by its ID, and set a value or programmatically click a button or something like that. Make sure you're doing code coverage tests. So a tool like Emma that will tell you you have 82% coverage of your code, and it will actually tell you which lines of code are not covered by any single test. Those are ones you probably want to write tests for very quickly. And then logging. Different versions of logging, so you can turn it off at compile time so it doesn't cost you anything. But if you're debugging the issue, you can kind of crank it up. We have inside, every time we do like a big release of Gwt, we want to make sure that we didn't break any APIs. And because Gwt has this kind of special way of writing code, we don't get complete coverage by a traditional Java diff tool. And so we've written this tool called the Gwt Api Checker. And what it does is look specifically at Gwt client code, the kind that can execute in the browser. And against 2 versions, it will tell you what's different, what's changed, what breakage you have. So especially if you're like a library developer, or you write code that other people on your team need to use, this is a great tool for different libraries. As far as big system design, people who start out with an application say I have a very complex application to build, or maybe it's grown organically and they're starting to see a lot of spaghetti code and they're like, how do I untangle this? What are some good design practices? At Google I/O this year, Ray Ryan gave a really good talk on GWT called GWT Best Practices. And that talk's worth watching. I've had people say I've watched it 16 times and I still learn stuff from it. There's lots of nuggets of information in there. What he talks about in that talk is basically 3 things: the event bus, the MVP pattern, which is kind of like MVC, but much better, and embracing asynchrony. That is, when you're building a web application, you have a connection to the server, but it's not a synchronous one. It's not an immediate one. And anytime you try to simulate that synchronous behavior, you're going to give poor user experience. What you want to do is just embrace the fact that the server's over there, and the server's available most of the time, but not all the time. Sometimes you're offline, the network connection's bad, sometimes it's just slow. Who knows what's going on? But your web application should be responsive even when the server's not there right that moment. And when you embrace this as a real pattern, a design pattern with your application, it can actually make your code a lot easier. That in combination with the event bus. Welcome back after the break. So we were talking about do or do not. There is no try. I think there was a short little green guy that said that once. So Gwt Api Checker is a tool that lets you compare 2 different Gwt APIs or programs or libraries and see what the differences are. So these are both the differences generated by the Java code and the inline JavaScript that you can put into your Gwt application. Let's see, already talked about Ray Ryan's talk, design. So another good tip is separation and specialization. If you're on a big team, you're in a complex project, as much as you can, if you can separate out different portions of your program and specialize them, it's going to kind of lessen the burden, remove the spaghetti, and make it easier for you to maintain. So the web is actually a pretty good platform for this, where you can have CSS, which describes a lot of the layout of the application, separate from the document object model and from the Ajax code. Also, in Gwt 2.0, we have something coming out called UI Binder, which is our declarative UI. It's a way of separating out. So today when you write a Gwt UI, you have kind of this swing model where you create a parent panel, then you create multiple children, and then you attach each of those children to the parent panel. And you kind of build up your screen this way. If you've ever done swing programming, this is very familiar to you. Many of our developers have asked for something a little more separated. They want their UI designer, their CSS HTML guy, to kind of be able to lay out the page, and they want to focus on the functionality. And so with UI Binder, we kind of give that to you. Instead of having this single Java class that composes this widget out of building blocks, create parent, create child, attach child to parent, and continue. You declare an HTML fragment or an XML fragment that represents the little bit of HTML that goes onto your page that represents your widget. So let's say you have again, the Google homepage, you have a little label that says enter your search here. Then you actually have a text box where the user can type something, and then you have a button, a little go button or search button. Those 3 components strung together. What you would do is you just write out the HTML for those components. You probably have an encompassing div tag or span tag, and then inside that you'd have the HTML for the label, a little placeholder. You'd have the input element for the text box, and then the button for the actual button. And then alongside that, you have another class or another file. This is a Java class which binds itself to the UI. So within the HTML fragment, you have different IDs or names, and those are uniquely tied to names in the Java class. And what this allows you to do is build out these complex compound widgets much more easily. The files are much easier to read, and you have this separation of concerns where your UI guy can change the divs to span tags and back and forth, and he can set other things and include CSS rules without having to affect the Java code that you write. So I think we'll see that this is a pretty popular capability. And then MVP, again, I should really recommend you listen to Ray's talk at Google I/O this year. But the essence of MVP is that you take the model, the view, and the presenter, and you put almost all the logic into the presenter. You put it in one place, and you make the model and the view extremely simple, requiring very little testing. So for the model, you can imagine a POJO, a plain old Java object. A simple object is kind of like a Java bean that has getters and setters, and that's it. It's just a storage bucket. And if you're representing, say, a person, you would have a first name property and a last name property. So you have a get first name, set first name, and a get last name, set last name. That's it. That's your Java class. Not hard. Once you've gotten that right, you don't have to mess with it, and very little unit testing that needs to go on. So there's no event hooks in there. There's no, when you call the setter, then this event change property fires, and you have to test that. That is kind of the MVC programming model, where you hook things together. If you recall MVC, and I'm sure almost all of you have a different idea of what MVC actually is, which is one of the problems. There's this triangular relationship between the model, the view, and the controller, and no one can actually tell you where any piece of code belongs. And if you want to test any of it, you always have to mock up the other two. And so it's very hard to build out your applications that way. Model, view, presenter, think of it more as a long string with the presenter in the middle, the model on one side, the view on the other, and the presenter doing all your work. Now, we talked about the model, which is really simple, just a POJO. The view is really nothing else than an interface that a widget can implement. And imagine, for example, a text box has a simple set text, get text. That's the interface that you want to declare. And so to test your code out, to test your presenter code, which is where all your logic is for kind of binding your UI together, all the Ajax-y stuff, you can create a mock object for your model. You can create a mock for the view, because it's just an interface with a get text, set text method. And then you can test your presenter. You can do really good unit tests. It's running in pure Java, so you don't need a browser to test, so you can run lots of tests really fast. And then when you do get to browser testing, you replace the mock object with a real view, which is just a widget, and you test only browser functionality. And hopefully you're reusing widgets or using standard widgets, so your testing, again, there is limited. The thing that the widget should care about, or the view should care about, is handling browser events, handling how to display things. What happens in a text box as I start to type? What happens when I hit the tab key or hit the enter key? Does that accept my input? Does that go to the next field? Those are the things that kind of happen at the browser level and may be different from one browser to the next. But they really shouldn't impact the coding of your application, of the core business logic. So that's just a little primer into MVP, but you should really watch Ray's talk and listen to it in detail. So here are a few testing tools that are in your arsenal. Gwt test case is a special instance of unit test, if you're familiar with JUnit, that allows you to run tests in the browser. You should avoid this if you can. Model view presenter is one of the ways you can do that, but you will have some tests that need to test the UI, need to test in the browser, and for that, Gwt test case. We also have Gwt mock utilities, which is a mechanism for disabling that special gwt.create method. This is the magic thing that the compiler does and takes this interface and generates code at compile time. Sometimes for testing, you actually want to turn this behavior off. You don't actually need a widget to be created. You don't need an IE specific version, a Firefox version. You want to test the core business logic. This is a way of doing that. If you're doing any internationalization, you probably want a fake message maker that will help you there. And then lightweight metrics. They give you basic statistics about how long it took to load your page before your page was up and running and interactive. And you can kind of hook in your own tools there. It's a good starting point. Here is the Debug ID that I referred to earlier, which here at the bottom half of the screen, you see how you kind of use this in your code. So I have a button, search button equals new button. That's how I instantiate the thing. And I have this extra line of code, the last line on the slide, that says search button.enable debug ID, and we actually pass in a little text string. Now this line of code can be compiled out completely, and the user will never see it. It's like it was never written. Or it can be compiled in if you turn on this gwt.enable debug ID flag at the top. So this is an optional flag that you turn on when you're building a build of your application for the QA department. And sometimes the QA department is you, but it allows you to use automated tools to test your application. But you can turn it off without doing anything else so that your users don't pay that extra payload. Some compiler arguments you should know. The Gwt compiler has a lot of special arguments, very powerful things that you can use. One of the ones that you'll look at as you're growing your application, making it bigger, is story of your compile, SOIC. What this program will do is it will take all your Java code and it will tell you how much of different packages and different classes and different methods are responsible for the actual bytes in the JavaScript of your application. So you may look at your JavaScript application and say, wow, that's 100K. Where did 100 kilobytes of source code or of JavaScript code come from? It just grew from 50K last week. What is it that I did that caused that to happen? If you run the SOIC report, you get an HTML report, and you can drill down, and you can find out exactly which packages are responsible for that. When you get into a new feature called developer-guided code splitting, we give you a way of taking your application and loading the initial portions of it when the page is loaded and deferring other portions later on. You can use the SOIC, story of your compile, to figure out where the fragments are. Why is it that some of my code is not being deferred to later? Why is it being loaded initially? Log level, just to see what's going on. And then enable assertions. This is normally a Java-C compiler argument. The exact same argument can be used for the Gwt compiler. And what it will do is actually enable assertions in your production code. So you can compile a version of your application that you can test with that has all your assertions turned on. Of course, you're using assert statements in your code. I hope you are. Now, as you dig into your source code, you may find that your application is growing quickly as you increase the number of RPC methods, or remote procedure calls, the number of client-server communications. And there's some of the reports that you can look at will show you actually which classes can be serialized and deserialized on the client. Now, remember when your application is compiled, you have Java code that has been compiled to JavaScript on the client, and on the server, you probably have Java code running. You can choose something else, but that's kind of the default scenario where JavaScript on the client, Java on the server. To make that happen, the compiled JavaScript code actually needs to know how to handle all the possible classes that could be serialized and sent from the client to the server or from the server to the client. And if you have an interface that you've defined, let's say you're building the auto-suggest feature on the Google homepage. So you want to make it so that when people start typing their search query, before they hit enter, you want to have results coming back from the server that will be displayed beneath the text box. So you hook up some JavaScript and you add a keystroke handler, and every time someone types a keystroke, you send a request to the server with the updated string, and the server replies back with the list of suggestions for the characters you've typed so far. When you when you do that, you have this method that you say, maybe it's called get suggestions. And it has a parameter that you pass in, which is a string, which is the string that they've typed so far. And the return type might be an array of strings. These are suggestions. So that's an easy case. So the Gwt compiler knows at this point that it has to be able to take strings and send them to the server, and it has to be able to take arrays of strings and ship them back. Now, if your application starts doing fancier stuff, let's say you have an address book and you start sending contact information back and forth and people back and forth. Maybe at one point you start making your methods a little more generic. Instead of having a shape as a return class, maybe you specify an object, just a Java object. And then suddenly the size of your source code balloons up and you go, what happened? Well, you dig through the logs, the RPC logs, and the Gwt compiler will tell you that since you specified object as a return type, and it has no way of knowing that you only plan to return strings or some subtype of it, it has gone ahead and created the serialization and deserialization code for every possible type or class in your application that you could possibly serialize. So that's bad. So you revert back and you say, okay, return type is shape. And so now I can return triangles and squares and all those things. In some cases, you're in that in-between scenario where you know that your application is only going to return squares and triangles and never ovals. But you look in the RPC logs, and the Gwt compilers tells you that, yes, it's made the serialization code for ovals. And you really want to eliminate that. This Rpc Blacklist will let you do that. It lets you selectively blacklist certain classes and say, I promise that I will never try to deserialize one of these classes. If you do, you get an error. But this is your control over how much code gets output into the application. When you're compiling, you're in that development mode. It's surprising that a lot of people develop with Gwt, and you ask them what their typical work process is, and you find out that they keep compiling their application, and they wait for the whole thing to compile and all the optimizations to happen. And then they test it in a web browser, and they make a change, and they go back to the beginning. And they say it takes forever to compile the application. And by forever, they mean it takes 30 or 60 seconds, because they've just started. That's not the kind of developer productivity that you're looking for. And what they're missing out on is they're not using development mode. Development mode is where you run your application in the JVM. So you launch it from within your IDE or from within the command line. And this will get up and running much quicker. However, if you do need that compilation, and let's say you just want to debug the JavaScript version, or there's something that's only happening there, you have a few options here to make that faster or better. The first one here is style pretty, which is the output style of the JavaScript. So by default for production builds, we compile to something that's called obfuscated style. That is, we produce the most optimized JavaScript that no human should ever read, and it's just computer parsable. Its method names are 1 or 2 characters, variable names 1 or 2 characters. Everything's all strung together, just looks like gobbledygook. Looks like the compiler puked. If you do want to debug JavaScript with say, Firebug, you turn on this flag, and what it will do is it will create a nicely formatted, lots of white space, will keep long method names, and it outputs some JavaScript that you can actually read. You can hold side by side by your Java code, and it will look very similar. You'll be able to find out, oh, that's this method, this line of code. The comments are still there. This is also a very educational way to look at your application and see what's going on. How is it that my application is being compiled? How is it different in IE than it is in Firefox? Why is it slightly bigger in one browser than the other? If you're doing a lot of these tests, we have a flag called draft compile. That is, forget all the optimizations. Just give me a quick and dirty JavaScript file that is functionally the same, but don't do all the hard work to optimize it. And then if you have multiple CPUs or multiple cores on your machine, use this flag, local workers. it lets the compiler use multiple CPUs to do these parallel processes. So if you're building for 4 different browsers and you have a 4-core machine, they can all build at once. So it can really improve your compile time. Let's see. I think we'll skip over this. So one of the founders of GWT is Joel Weber. He has this wonderful quote I always like to use, which is, the fastest code is that which does not run. And what he's referring to is the fact that the Gwt compiler will take your code and eliminate all the code that it knows you will never execute. That if-then-else statement that the compiler can figure out, you'll never get to the else block. So let's throw that code away. And then once it's done that, you don't need the if statement anymore because it's always true. So it gets rid of the if statement. And once you've done that, the remaining block inside of it is so small that it'd be more efficient if you just inlined that into the calling methods. So you get rid of that function call. And now the resulting method is a little bit simpler. So it can be inlined. And before you know it, a big part of your program has evaporated. This is how we allow you to create, or in fact, we have many different layers of indirection in our DOM library. So when you call set inner text, if you ever step through that code in your IDE and try to find where's the actual line of JavaScript that gets executed for IE or Firefox, you'll see that you're going 3, 4, maybe 5 levels deep before you get to that. If we shipped all of that to every one of your users would pay for that extra download. They would pay for the execution time as the browser has to make 5 method calls and go 5 levels deep in the stack. But in fact, the Gwt compiler makes all of that go away and just inlines the call. So you and your code have this pretty method that you call. At debug time, you still get to step through all those methods. So they all exist. You get your productivity. But at runtime, it all just disappears. So that's a little bit around the Java transformations where dead code elimination happens, the method inlining. We do also constant folding and propagation. That is, if you have an expression in your code that refers to a constant defined somewhere else, we can just inline that constant because we're compiling your code. And then we can take the resulting expression and inline that, propagate it further in your code, and make a lot of those calculations go away. We do some other things in JavaScript land as well, and we keep discovering more ways we can improve things here. So for the longest time, we worked on making the JavaScript as small as possible. If there's 2 ways to represent something, and one is slightly more compact, fewer bytes, or executes slightly faster, we use that. We can go through multiple iterations. But then the other day, someone on our team was looking at things, and he said, well, you know what? We're working on this uncompressed JavaScript, just the core file. But in reality, every time a browser and a web server talk to each other, it's almost always over a gzip connection. That is, the browser says, give me this file, and oh, by the way, I support gzip. And the server usually responds, here's that file, and I've gzipped it for you, which is I've compressed it over the wire, so there's fewer bytes to transfer and download over the network. So really, the size that matters to us for network bandwidth is the compressed size, the gzip size. So what does that tell us? Can we do anything about that? We can't change the compression algorithm because that's baked into every browser and every web server. But we do know what the algorithm is. And it's the variable length encoding algorithm where basically the algorithm is looking for strings of text that repeat themselves and compressing those down and turning those into references. So if I see the name Fred appear 12 times in a file, I can kind of compress that down to one instance and then a bunch of pointers back to that original version. And that's kind of the basic form of compression. So now we have this big JavaScript file, which is your application. Maybe it's Google Wave, tons and tons of code. What if we did some reordering tricks? What if we took all the methods that looked kind of similar to each other and we kind of grouped them together? They're all top-level elements. Let's kind of sort them, just sort them globally. So we take our raw JavaScript and we just sort it. And we see what the compressor does. gzip compression. It turns out if you play some of these tricks and you do some other things like rearranging arguments, for example, the compiler would produce this code where we'd have this function with 3 parameters, A, B, and C. And the next time it needed a function with 3 parameters, it happened to be on a different letter, and it said HKL, and then OXV would be the next one. We're like, well, what if we made them all the same? What if we said functions always start with parameter A, and then use B, and then C? And if we change some other ordering and try to make things more consistent that used to be random, what would happen? So it turns out you can get, I think it's up to about 20% improvement in the compressed size of the JavaScript and doing nothing with the original JavaScript. It's still the same amount of size, or it's the same size. It compresses better over the wire. And so these are some of the latest tricks that are making themselves into the Gwt compiler. And Gwt is one of those very interesting libraries and frameworks where you can take your existing application, you can just wait 6 months, and then you recompile it and redeploy it to your users, and it's smaller and it's faster. Yet we've added more features. And this is kind of a paradox, but it shows you how the power of doing this whole program static analysis. You pick any other library out there, and you're probably going to see it grow in size if nothing else. You may see performance benefits just in runtime execution, but more than likely you're going to see the download size increase. So if you have a JavaScript library, every time you get a new version with more features, it gets bigger and bigger. And certainly when libraries reach a certain size, they start to split themselves. They say, okay, well, we'll give you optional components. If you want animations, then you load this JavaScript file. If you want that one, then you load that file. So you start increasing the number of HTTP requests. And of course, if you have a complex application, you want all the modules. And so you gain no benefits. Now, if you ask me, so what's the overhead of Gwt? How many K is it? Well, if you write an application that just says window.alert hello world, it's almost nothing. There is a little bit of overhead. So very tiny applications, Gwt is maybe not that efficient. But the more you use our APIs, kind of more the overhead grows. But it grows very gradually with the number of features you use. And that's because we don't just have a big library that we ship alongside your source code. No, the input to the compiler is all of our APIs, all of your source code, all of the third-party libraries that you've included. We bake them all together. We put them in the oven. We take only those pieces out that your user actually uses. We follow the code path down, and we see exactly which lines of code get executed in our APIs. And if you never, ever request say the size of the current browser frame, then that method does not get compiled into your source code. It just does not exist. We can do some other tricks as well. Java has class metadata. And it turns out if you call class.getName anywhere, that Gwt has to essentially bake in all the class names into the output. And you end up with all this extra overhead. So if you have a package com.example.foo.myapp, then somewhere in the JavaScript is that string, com.foo.example.myapp. Now, you as a developer know that maybe you don't rely on that. We can't know that. So we give you an option to turn it off. This is this disable class metadata compile parameter. And when you turn that off, we've done it on a fairly big application. We saw about 5 to 10% improvement in the JavaScript size. So that's a pretty big bang for a simple command line parameter and maybe a tweak to a line of code here or there to do something differently. Here's another little trick, which is disabling type checking or class cast exceptions. You can turn these off, and then the striked out lines of code will just disappear. They won't happen. So Gwt is all about speed, performance for your users, and there's some real reasons behind that why we care so much about speed. And that's because human experimentation has shown that we can roughly perceive actions that happen in longer than 100 milliseconds. We can perceive them as distinct actions. Anything that's faster than 100 milliseconds, or about a tenth of a second, seem instantaneous to us. We really can't perceive them. So if you have an Ajax application and you return control to the browser thread within 100 milliseconds, so no matter what action the user does, you give the response time back, the application will feel very snappy and responsive. Anytime you communicate to the server, if you do that asynchronously, then you prevent kind of lockup of the browser event loop. As soon as you exceed that 100 milliseconds, the application starts feeling sluggish. So this is kind of a hint that you should probably measure your application pretty religiously. If you can take every single task that the user can perform and you can somehow get it under 100 milliseconds, your app is just fast. If you get it to about a second, which to me is an eternity when using a web application, it starts feeling disconnected. I clicked on something, and then a second later something happened. And I'm not sure anymore if that happened because I clicked or that that just happened on its own. There's another reason that speed matters, and that is when users use your application, every time they do something and they see the effects of what they've done, they have an opportunity to learn. They have an opportunity to experiment. If they can do this very quickly, they can become expert users of your application very quickly. If it takes multiple seconds after they've clicked on something, they start to become hesitant and they don't learn very much and they don't use the features that are in your application. They're constantly afraid that it might take too long. So lots of reasons to care about performance. I alluded a little bit to developer-guided code splitting, which is this ability to take your gigantic application, everything that you've written, and to actually break it up into pieces. And then only download the portion of the application that you care about to make the application responsive and defer the other pieces. For example, let's say you're building Gmail. The address book is not something you need the instance you get in your email. It's a piece of functionality that you could defer and download later. So that simply looks like this. Instead of downloading everything, we download a little chunk and then we split up the app. Of course, if you have your big application, it looks kind of like this, and you don't know where to split things up and keep them maintained. So we have this little abstraction called run async. This is the way that we help you chop up your code. You just write this little snippet of code, and then everything that you want to defer, like instantiating the address book and everything that you want to do there, you put in the onSuccess method. And the Gwt compiler will recognize this, and it will actually split your source code and figure out all the parts that are reachable from that address book and all the parts that are reachable from the main application, and it will divide your application up into separate JavaScript files. I won't go over all of this. So I talked a lot about image bundles, client bundles. This is what they actually look like. To bundle those 11 sprites together, you write this Java interface, and you simply provide these methods. So like this line right here, abstract image prototype, OK button. Right there, that tells the Gwt compiler that there's an image in this directory with the name okbutton.gif or .png, and this here, cancel button, I've actually given it an explicit file name so it knows to look for btn_cancel. And the Gwt compiler will take all the images referenced in this interface and compile them together, magically create that sprited image for you, create the checksum, create the special file, put it in the output directory, create the CSS to split those images up. It does all of that for you. The only thing you need to do is take your images, throw them in a directory, and write a file that looks like this, where you list all the names of the files. And then from there on out in your application, you can just refer to OK button or cancel button, and you'll get a handle to this image. And Gwt will do all the hard work for you. Client bundle in Gwt 2.0 takes things a lot further. We can inline data resources. I mentioned CSS. Let's see. So let's say we can do other fancy things with images using internationalization. So imagine I have a Pay Now button on my application. and that's for the English version of my site. I also have a Chinese version, a French version of my site, and the width of that button is a little bit different depending on the language, just because the text is different in each language. How do I deal with that in my application? So with these resource bundles, you can use these methods here where you actually get the URL, get the width, get the height, and these become compiled in inline constants in your application. But the English version of your application will have different values for those constants than the French version of your application. And so just how we compiled a different version of your app for IE and for Firefox, we can compile a different version for each language of your application, yet not pay for any runtime checks to figure out the width of things. All of it's hard-coded. So I'm going to skip over some of the logging because I know we're running a little late on time. So roadmap, what's ahead for this last release of the year is development mode, which I talked about today, which is really running any browser, any of the major browsers on your platform with this plugin and getting all that productivity. You can also run remote browsers. So let's say you're on a Mac and you develop there, but you have a VM with IE6 on it, and you have a version of Firefox running somewhere, and you have another guy that has some different version of Firefox, and he's always able to find issues that you can't find on your apps. With development mode, you can use that remote browser and just point it to your machine. So you can use a Selenium farm. Like I said, you can use a VM and just debug your browser. The declarative UI, developer-guided code splitting, the client bundle, which is really the image bundle on steroids, story of your compile, and more features I really haven't talked about, but these are kind of the big hitters. To read more, this is the main page for GWT, code.google.com/webtoolkit. My contact information, if you want to ask any questions, and be happy to take any right now if you have any. Thank you. So the question is, how robust is the new development mode, the plugins? I would kind of qualify it as beta and soon to be released. Internally at Google, we're using out-of-process hosted mode or the new development mode for pretty much all of our projects. We're all running Gwt 2.0, or at least the latest version on SVN trunk. Our projects can run maybe a week behind, but we're pretty much on the leading edge. We always want the latest features and capabilities. So if you're willing to kind of live close to the edge, then probably work quite comfortably. If you want everything to be completely streamlined and perfect and have no issues, then it may be a little bit early. So I think I've basically described what a beta is. Is it faster than the current hosted mode shell? I would say yes, especially because the hosted mode shell, you would frequently end up launching it. Even though once you're building an app, the best practice was to just refresh, and it would kind of recompile your application or pull in the latest version. But in practice, it seems like you ended up terminating that hosted mode shell quite a bit and then having to bring it back up, and that was a little bit slow and sluggish. The new plugin just uses any existing browser. So as quickly as you can close a tab or open a tab, you can have that environment ready. The remaining overhead of actually launching the hosted mode or the new development mode is probably the same as hosted mode refresh. So we're dealing with the same translation technology, the same injection stuff. What's different is you're not starting up a browser from scratch a lot. So I think it's probably a net improvement of speed, but it's a little different in the way you kind of work with it. It's great that you can now have multiple tabs. You can actually use development mode. You can have a Firefox browser running, and you have Safari running, and IE, and they're all connecting back. And you before you just had that hosted mode, and it was baked in one version of the browser. And to test a different browser, you had to either compile your application, which is where all these fancy compiler flags came from, because people did have to do that, or you had to test on a different platform. And so that's kind of the big feature, that now you get this native support for all major browsers on your current platform. And I think that is a huge net productivity win that is really going to make people happier. Can GWT take advantage of Chrome Frame? What's the story there? Yes, most definitely. All you really need to do for your application is in your main HTML page, just insert the Chrome Frame meta tag. And if your users have Chrome Frame installed, it will use it. It just works. There's really nothing more to it. If you like, you could encourage your users to install it. You can instruct them how. It depends what your environment is. So if you're completely agnostic, you just add that meta tag, and users that have it will get the Chrome Frame experience. If you're in, say, a closed environment where you control the desktops and you specifically want to roll out the capabilities of it, then you obviously can control the desktops and get the plugin installed. You can encourage it. It's completely open to you. Okay, so which major versions of phones support HTML5, CSS to run Gwt applications? It's a tricky question because there is a really broad range, but I think you see kind of the top ones are easy to pick out. So you have Android and the iPhone and the Palm Pre. They all kind of run kind of these very new browsers. The WebKit rendering engine seems to be the rendering engine of choice for mobile devices. Any new phones coming out seem to have really good browsers, is at least the majority of the time, if not all the time. There's a large number of phones out there that have less capable browsers or older browsers. And with GWT, to really take advantage of it, you need JavaScript capabilities. So that's kind of the bare minimum entry point. There's nothing that you can't do in GWT that you could do in the JavaScript library. So if you can build an app for that phone, basically if the phone is capable of the functionality that you need, you can do it inside of GWT. When you get to the point where the mobile browser that you're targeting, or just the desktop browser you're targeting, is greatly divergent from kind of the mainline code base that we support directly, then it starts becoming more work on your part. So if you just take an application like Google Wave, for example, they built a mobile version, and I think the team quoted something like 5 or 10% additional effort to build the mobile version. And that was not because the browser had different capabilities and that they had to do other JavaScript stuff. It's simply that the form factor of the device is different, and that they have to create a different user experience on the mobile device. And that's really where your time's spent. So if you just take GWT and you build for, say, the Android, the iPhone, the Palm Pre, I think you can spend probably 95% of your time focusing on the user experience, on building the application. So that thing that you want to be doing, that makes you valuable as a developer, is building the application. If you start building for devices that have been out longer or older, or have older versions of browsers, you slowly start to increase the amount of work that you need to put into it to maybe create the user experience you want. Sorry, it's a long answer, but mobile space is evolving so quickly that you're almost always talking about the leading edge is where everything's at, and everyone else is antique, even though they were the hottest thing 6 months ago. But the good news is that these browsers are really keeping pace on the mobile devices. Thanks. Does Gwt play well with IE6? And the answer is yes. So we're in this situation where, let's see, when was it? I think it was Gwt 1.6, where we added support for IE8. Basically, that was the point where the additional functionality into IE8 was such that we really wanted to take advantage of it and wanted to kind of pay the compilation cost of an additional, what we call compiler permutation. So today when we build your app, we use, I think it's 5 or 6 different versions of the browser. In my example, I was talking about 4, but we have an IE6 version, which is really IE 6.7. We have a WebKit version, which would cover Safari and Chrome and anything else WebKit. We have an Opera version, and then a Gecko version. Gecko is, Firefox, Mozilla, anything derivative of that. And then IE8, if I did not mention that one. So IE6 definitely works. I think in the coming, if I look like a year forward, we're going to start seeing really good advances in HTML5, the new CSS support. Rounded corners are going to be like a first-class citizen in the browser. And we're going to start to see capabilities in the user interface that really can't be done very well in IE6. And I think our commitment on GWT side is, as long as IE6 is a prominent browser that our developers have users for that they want to support, we'll continue to support it. But I think we're going to see the shift where some of the functionality is not going to be quite equivalent. And I use rounded corners as an example because that's a good one where you could imagine that, let's say in IE6 we do square corners and all the other browsers we do rounded corners. And maybe as time goes forward, there's other decisions like that where we could, for example, in newer browsers put in CSS animations, but in older browsers do those animations with JavaScript. But you get to a point where the older rendering engines are so slow that your animations would be choppy and wouldn't work anyway. And so you have to, at some point, kind of cut it off and say, OK, we're just not going to do that animation. It's going to be instantaneous. We're not going to have the rounded corners. But we still have a functional user interface. So a very long answer to, yes, your apps just work on IE6. OK. So the question is about, was it AMF? AMF protocol that, a binary protocol that Flex uses to communicate between the plugin or the Flash client that's installed in your desktop and the server. And how does GWT compare performance-wise? How would we download a large amount of data to the browser efficiently? I think the answer is that we're pretty close in GWT to about as efficient. You can make HTTP, XML HTTP requests between client and server. We have a pretty compact format. There's probably a couple of optimizations we could make to make it slightly better, but I think we're pretty close. We're not ever going to, at least until the browsers support this, get as close to a binary format. And the reason is simply that JavaScript can't parse arbitrary 8-bit or binary data. JavaScript is essentially hardwired into UTF-8. So you can pass in Unicode characters, but you can't do arbitrary compressions and just pass in binary data. So over the wire, there's this restriction that browsers today can only do UTF-8. Having said that, the effective channel between client and server is almost always a gzip compression. So in fact, if you send plain text over the wire, the actual bits that are coming across will be compressed. So the situation is actually better. You don't have to deal with the binary overhead. You can just do plain text, and the communication channel does the extra work for you. So the question is about that compression looks good, but now you have still the parsing overhead where a Flash client could take this binary data and kind of process it immediately. That is true. The JavaScript engine in the browser still has to take whatever data you send down the browser, down the wire, and parse it. The fastest way to do that today is probably a JavaScript eval, where you just inline a set of JSON code and have the browser scoop that in. Luckily, there's some browsers that are making really big headways into JavaScript performance improvements. And so I think we're going to see that difference become smaller and smaller and smaller over time. But right now, I'm sure there's a measurable difference. So there's some comments about you can, on the web, find some comparative results between the different formats and James Ward blog. Okay. The other thing is that nothing precludes you from combining GWT with other web technologies. So one of my projects, for example, is GWT Voices, which is a sound library that allows you to create sound in the browser. And if you don't have any plugins, I do the best that your browser can do. So some browsers can play WAV files because that was the coolest thing in the 90s. Other browsers can play some other formats, but it's very unstandardized. There are no two browsers that can play a sound in the same way. So I have a different implementation for every single browser. And then, of course, we compile 4, 5, 6 different versions of your application. But one of the things that I've baked into that library is detection for a Flash plugin. And if you have Flash, and you try to play an MP3 file, I do that via Flash. And you can very easily take your Java GWT code and bridge it over to Flash, and you can make use of plugins. Others have done the same thing when they have a particular Flash library that does charting really well, or other graphics, or churning of data. Really, anything that you can do in JavaScript, CSS, HTML, including integrating with plugins, you can do in GWT. So you don't have to give it all up just because you want to use something else. Gwt plays really nicely with anything. Yes, so great question about searchability of Ajax applications. And actually, I think it was this past week, a couple of members of the GWT team went to, I want to say it's the SMX conference, the kind of a webmasters search engine conference, and talked about some of the work that they've been doing inside GWT to make it easier to make Ajax applications searchable. The key problem is, if you recall the slides that we had with the hash fragments, that we go to this one URL that the server would see, which is our main page, and then we could spend an hour in that application moving around state, making HTTP requests to the server, grabbing bits of data, but the URL, only the hash fragment would change, or maybe not even that. If a web crawler comes along, so like a search engine crawling your website, it will just see the main HTML page and then a reference to this JavaScript file, and then it's done. It doesn't know anything about the content of your website. It can't find it. So the traditional solution to this has been, well, you create another version of your website, the static version. This is the version that crawlers see. This is the version that people with JavaScript disabled see. People on mobile devices or web browsers that are just older, that don't do JavaScript or don't have all those capabilities. So you have kind of a static HTML version. Of course, you're serving up the same content, but you're just formatting it different because it's being consumed differently. So that's a big pain. And what the GWT team came up with is a different way of processing those hash fragments, turning them into URLs, and then kind of magically converting those URLs with query parameters back into hash fragments. There's a link on the Gwt blog to the details of this. You can look through it. You can also look on the Subversion trunk and kind of walk through how this works. But the short answer is I think we've figured out a way to do it, given the constraints of current browsers and crawlers. And the GWT team has now proposed this new way of going about making applications searchable. And what we need is for people to kind of jump on board and say, yeah, that looks good, and I want to implement it. And I think then if we can get this adopted as a standard, we can all have our applications searchable with minimal effort.